Script. Hey everyone, and welcome. Today we're tackling a Leetcode problem that sounds simple, but has some interesting little details. Counting hills and valleys in an array. We'll break down what that means, walk through an example, and explore a couple of ways to solve it. Let's get started. Script. Okay, so the problem asks us to count the number of hills and valleys in a list of numbers. We're given an array which is just a list, called nums. Our job is to go through it and add one to our count for every time we spot a hill or a valley. Script. So what exactly is a hill? Think of it like a peak in a mountain range. A number is a hill if the first different number you find to its left is smaller, and the first different number you find to its right is also smaller. It has to be strictly taller than its nearest different neighbors. Script. A valley is just the opposite. It's a dip. A number is a valley if its closest different neighbors on both sides are larger than it. It's sitting at the bottom between two bigger numbers. Script. Now there are a couple of really important rules. First, the endpoints of the array can't be hills or valleys, because they're missing a neighbor on one side. Makes sense. Second, and this is the tricky part, if you have a flat section, or a plateau, like a bunch of 4s in a row, that whole plateau is considered a single hill or a single valley. We only count it once. Script. Let's walk through an example to make this concrete. Our list of numbers is 2, 4, 1, 1, 6, 5. The first number, 2, is out. It has no left neighbor. Next is 4. Its left neighbor is 2, which is smaller. Its right neighbor is 1, which is also smaller. Perfect. That's a hill. Our count is now 1. Next is the first one. Its left neighbor is 4, which is larger. Its right neighbor, well, the next one is also a 1, so we have to look past it. The next different number is 6, which is also larger. So the number 1 is a valley. Our count is now 2. What about the second one? The problem says adjacent equal numbers are part of the same valley, so we don't count this again. Next up is 6. Its left neighbor is 1, which is smaller. Its right neighbor is 5, which is smaller. That's another hill. Our count is now 3. Finally, the last number, 5, is also out. No right neighbor. So our final answer is 3. Grit. So how can we write code for this? The most direct way, as shown in the editorial, is to just follow the rules we just described. We'll create a loop that looks at every number that could be a hill or valley. That means everything except the first and last elements. For each of these numbers, we'll perform 2 searches, one to the left and one to the right, to find those all-important closest different neighbors. The script. Alright, here's the Python code that implements this idea. It might look a little intimidating with the nested loops, but don't worry, we're gonna break it down, piece by piece. Script. First, we set up our result counter and get the length of the list. Our main loop, using the variable I, goes from the second element up to the second to last. The very first thing we do inside is a check. If the current number is the same as the one just before it, we just continue to the next iteration. This cleverly handles those plateaus we talked about, ensuring we only evaluate the first number in any flat sequence. Script. Next, for a given number at position I, we need to find its left neighbor. We start another loop with a new variable. Let's call it j, starting just to the left of I and moving backwards. As soon as we find a number at j that's different from our number at I, we record whether it was smaller or larger in our left variable, and then we break out of this search loop. We've found what we need to call script. We do the exact same thing for the right side. We start a j loop from the position just to the right of I and move forward. The moment we find a number that's not equal to our current number, we update our right variable and break the search. Script. Finally, we check our left and right flag variables. If both of them were successfully updated, meaning we found a neighbor on both sides, we then check if they follow a pattern. If left is -1 and right is -1, it means both neighbors were smaller. That's a hill. If left is +1 and right is +1, both were larger. That's a valley. In either of those cases, we increment our result. Script. So how fast is this approach? Well, because we have loops inside our main loop, the time complexity is big O of n squared in the worst-case scenario. Imagine an array where you have to scan almost to the end every single time. However, it's very efficient with memory. It uses big O of 1, or constants, space, since we only need a few variables to keep track of things. Script. Now, that n-squared solution works, but can we do better? Yes. A much more common and efficient pattern for this problem is to use a two-pointer or filtering approach. The key insight is that plateaus are irrelevant for identifying the shape. So, what if we first create a new, clean list that just removes all the adjacent duplicates. After that, finding hills and valleys is super simple. We just need to check if a number is bigger or smaller than its immediate neighbors. This approach is much faster, running in big O of n time script. So to wrap it all up, the most important part of this problem is carefully reading the definitions for hills, valleys, and especially how to handle those flat plateaus. A direct nested loop approach gets the job done, but isn't the most efficient. A better strategy is often to clean up the data first, in this case, by removing the plateaus, which then allows for a much simpler and faster single-pass solution. Script. Hope that breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. And hey, if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.